Somewhere over the rainbow of red and green and blue, all the pretty colors that we need to do our hypothesis test, let's organize it by putting it into a table called the ANOVA table. Why don't we just jump to the end where we get the F statistic? Why organize things in a table? Because without the table, it would look like this. Does anybody want to see this?
First of all, that's horrible.
No, they do not. So instead, we're going to put it in a nice, pretty little. Here, the red, we're talking about how spread out those means are. For the green, how spread out is the data. And here for the blue is that total piece, which we're not going to need to make this F, but it's still going to be useful, so we're talking about it now. What things do we have? We have K for the number of groups. Why is it that K stands for the number of groups? Because K is for categories.
Your spelling hasn't improved.
Look, I don't know, okay? There's 100 years of tradition going on here, so we're just going to have K be the number of groups. The example we were looking at before had 4 groups, so K minus 1 would be 3 for this box. N being the total, it looked like in that other one there was, 15 dots in each group. If that was true for all the groups, 15 times 4, we're looking at 60 total. That would be our capital N, the total overall. So N minus 4, 60 minus 4 would give me, 56? That's my degrees of freedom here. For the total, it's the big capital N minus 1. These are degrees of freedom, and we're going to use those when we go to the applet. For the sums of squares piece, this is what we talked about with the SSG. Here's the SSE, and there's the SST. Those are hard ones. That's why we spent a whole video slowly going through each of those and how you derive them. This is the MSG, and to get that, you take the second column divided by the first column. The sums of squares divided by the degrees of freedom. So SSG over the DFG, degrees of freedom for groups. That's how we get the MSG. And then MSE, this is the sums of squares error divided by the degrees of freedom for error. This MSE is actually an important piece. He's like a combined overall how spread out is the data, like a pooled variance across all the groups. To get the F test, we take the MSG divided by the MSE, the variability between the means divided by the variability inside the groups. Once you have that F value, you can go to the distributions applet, change it to be F, and you'll notice now we have degrees of freedom N and D. That's degrees of freedom numerator and denominator. The degrees of freedom numerator is going to be the K minus 1. The example we had before, it would have been 3. The degrees of freedom denominator, that's the capital N minus K. For the example we were using, it was 60 minus 4, which was 56. So you put in those degrees of freedom, you put in your F value, and it gives you a P value. The F test is always going to be right-tailed, because if you're close to 0 and you were adding up things that got squared, the only way you're going to get close to 0 is if those things were all pretty much 0. 0 meaning the means were very close together. So over here is where the null hypothesis always lives, and then out here in the tail is for the rejection region. If you get a small F value, those groups really weren't that different. We can't say that the means are different. But if you get a big F value, you're going to have a small P value, and you're going to say, yes, those groups are very different. That means over here, we're going to fail to reject the null with our large P value. Over here, we're going to reject the null with our small p-value. So what's it like to do ANOVA? You get the overall average across all the data. You get the average for each of the groups. You get the standard deviation for each of the groups. Calculate out your SSG, calculate your SSE, fill in your degrees of freedom, do the total at the bottom row, do the MSG, MSE, divide them to get your F, go to the applet, get a p-value, and from there the rest of the hypothesis test should feel pretty much the same.